This video is for Chapter 10, Section 1. It's all about area of parallelograms and triangles. This lesson comes right after we just studied area and perimeter in general. Perimeter being the length around any figure, and area being the amount of space taken up inside that figure in square units. So one of the first things we're going to talk about is height. For the area of a rectangle, we learned that it was base times height, and the base and the height were perpendicular to each other. Most figures that we study will have something called a height. So any segment perpendicular to a line containing the base of a figure drawn from a vertex or a side opposite the base. Base and height must be perpendicular. Here are some examples of height that we want to write down before we start studying these shapes. In a parallelogram, a height is the distance between parallel sides. That's not written on this slide, so I'll say it again. The height is the distance, perpendicular distance, between the parallel sides. In a triangle, the height is just another word for altitude. From a vertex, perpendicular to the opposite side. So height and altitude are the same thing. In a trapezoid, the height is the perpendicular distance between the parallel sides. So these are three areas where we will want to see these segments as being called height. Now, the first segment for this lesson is, or not the first segment, the first shape is parallelogram. We're going to look at the area of the parallelogram by studying this parallelogram here. It has a base and it has a height. Now it has a third side, it has a side here, but we're not going to worry about that side. Rather, we're going to cut off this right triangle and we're going to move it to the other side. So there it goes. And now our parallelogram has been turned into a rectangle. And then the parallelogram looks like a rectangle. Therefore, the area formula is base times height, as long as we remember that the base and the height must be perpendicular. Now here's an interesting shape. It's a parallelogram. We have a base along the bottom and a height that is perpendicular to it. But we also have a second base for the parallelogram, and here's a second height. Now this becomes one of the toughest parts of this lesson, is that base 1 times height 1 equals area. But base 2 times height 2 also equals area, and the area does not change. So all parallelograms have two bases and two corresponding heights. The height must be perpendicular to the base. I could move height 2 down here and we could see it as being a height. I just didn't want it to cross height 1. So here's an interesting question. What if base 1 was 10 and base 2 was 13 and then height 1 was 12? Could we figure out what the area of this parallelogram is and then find the value of height number 2? So let's put the numbers in. Base 1 10, height 12, base 2 13. Well, first we start with the easy part. Area is equal to base times height. Now if area is equal to the base 1, which is 10, times the height, which is 12, we get the area is equal to 120. Now the area of this shape does not change. Therefore, if I said the area is equal to base 1 times height 1, it should also equal base 2 times height 2, as long as they are corresponding to each other. So it should also equal to the base of 13 times the height we are missing. Which means I can take that 120 answer that we have here and I can divide by 13 on, and I'll end up with, if I divide by 13, that this is approximately 9.2 is my second height. A formula we may want to write down is that base 1 times height 1 will always equal base 2 times height 2. Because the area of the shape does not change. All right, let's move forward. Triangles. Now, triangles have 3 bases and 3 heights, but we're going to focus on this base, and here's its altitude creating a height. The key to a triangle is use an exact copy of the triangle, flip it over, and attach it to the matching side. Looks like that. Boom. Now we got 2 triangles, and the shape has been turned into a parallelogram. Now, 1 triangle is half of that parallelogram. And we just learned that the parallelogram formula is base times height. So therefore, the area of a triangle is 1/2 base times height, because it is 1/2 of this parallelogram. This is 2 triangles. 2 triangles equals base times height. So 1/2 of base times height is 1 triangle. Let's take a look at some examples and be done. First of all, the first example we have is this obtuse triangle. This seems to always throw students off because we have to identify when we look at this triangle. Area equals 1/2 base times height. But what is the base and what is the height? When I look at this problem, the height is obvious. It's the 6 feet. It's how high is that point? 6 feet. The hard part is understanding the base. The base is not 12 and it's not 3. The 3 is just showing you how far out I had to go to draw the altitude. The base is 9. So my area is equal to 1/2 9 times 6. I'll take half of 6, which is 3, times 9. So 27, in this case, feet squared. That's example number 1. I'm going to erase this and look at example number 2. Example number 2 is what's called a composite figure. It's made up of a parallelogram and a triangle. So I'm going to write a plan. My area is equal to the area of the p-gram plus the area of the triangle. Now, the area of the parallelogram is base times height, and I'm putting a little p there because it's the base of the parallelogram times the height of the parallelogram, plus 1/2 base of the triangle times height of the triangle. Now, the base of the parallelogram is 12 and the height is 8, so I got no problem here. 12 times 8, so that's 96. And I have 1/2 of my base of my triangle, which is 6. And the good thing is the height of my triangle is still 8. Same thing. So, times 8. So that becomes 24. 96 plus 24 is 120 centimeters squared, and we have our area of our composite figure. Now, to finalize a couple examples, we have some special right triangle examples. Just want to put these in here so we have them in our notes. Here's a parallelogram, and we need to find the area of this shape. But we're only given one side 10, and I don't even consider it necessarily to be the base. So I'm actually going to have to add a little more information in here. I'm going to put that this side is 12. Have to have that there. Now, I know that my area is equal to base times height, and my base is equal to 12, but I don't know what my height is. So I'm going to use that 30, 60, 90 right triangle. 10 is the hypotenuse. The short leg is 5, and the height is 5 radical 3. So now I know that my height is 5 radical 3. And I have a base times height. Area equals 60 radical 3 units squared. And that is an exact answer. Go to my triangle, 45, 45, 90. We go back and try to study on this. How do we find the side lengths of a 45, 45, 90 triangle? Well, if the hypotenuse is 12, we have to divide that in half and put on a rad 2. Now that was a simplified way of looking at it, but you have to go back and look in your notes on special right triangles. We should be at this point now. 6 rad 2 times rad 2 would equal 12. That is now my base and my height. So my area is equal to 1/2 6 rad 2 times 6 rad 2. When I break this down, I have 1/2 of 6 times 6, which is 36, and rad 2 times rad 2, which is rad 4, which is 2. So I can now do 1/2 of 2, which is 1, and I'll just end up with 36 units squared. That's it for the examples, and that's it for Chapter 10, Section 1. You can begin working on the assignment.